Welcome to the 5G neutral hosting screencast. The aim of this screencast is to demonstrate the successful 5G neutral hosting use case by setting up an edge virtualized environment in a scenario where two radio access network baseband units, each serving a separate mobile network operator, are deployed on the same host. The Universidad de Malaga facilities, which included external antennas, Benetel radio units, and an ICE wireless BBU deployed over one Open Nebula telco cloud with two VDCs and Open 5G cores were used to test the working connectivity between the user equipment and the 5G core. We must configure Open Nebula first. Create a set of user groups, users, virtual networks, and separate virtual data centers to enable the resource isolation. Firstly, let's configure the user groups. We must create a separate user group per each operator. Navigate to System Groups tab and click the Create button. Newly created groups are added to the default virtual data centers. Let's define the group name and toggle the switch that creates the group administrator. It's a special user that has permissions to add new users, and manage resources in the defined group. Define the name, password, and the authentication mechanism for the user. For the purpose of this screencast, the permissions and views are left as is. However, feel free to fine-tune it according to your preferences. Once both groups are created, we must proceed to the new user creation. We must create one user per each mobile network operator. Navigate to the System Users tab and click the Create button. Define the username, password, and authentication mechanism for this user. Now we must select one of the previously created group that corresponds to this user's mobile network operator. In this case, we only need our users to be in their respective primary groups, so the secondary group should remain empty. We must create the RAN midhaul and backhaul networks per each operator. Navigate to Networks, Virtual Networks tab and click on the Create button. We will start with creating the midhaul network for our first operator. The network type is going to be bridge, using only private host networking and with custom bridge name. After that, we will define an address range for the virtual network, starting with 172.27.0.10, and it's going to contain 50 consecutive IP addresses. For the purpose of this demonstration, no security group or quality of service needed, so we're going to leave them as is. The rest of the networks must follow the same configuration pattern, but with slight difference. Backhaul networks are configured with .1Q type interface and are bound to a physical network card. As the final touch on networks, we must change the ownership of each network and set it to their respective mobile network operator user and mobile network operator group. The final step of the configuration is to create a separate virtual data centers per each mobile operator. Navigate to System VDCs tab and click the Create button. Define the virtual data center name and proceed to the group assignment and resource selection. Select the user group. Select the clusters, data stores, hosts, and virtual networks that will belong to this virtual data center. Now we must repeat the same steps for the second mobile network operator. During this part of the demonstration, we're going to show the deployment of the end-to-end 5G RAN using the OpenNebula Cloud platform. In this screen, we have OpenNebula Cloud instance, user equipment, in this case it's a phone, which will be attached to the 5G network, and terminal, where we will check the deployment process. Inside the image section, we have the CU appliance image. In the virtual template section, we have the CU appliance template pre-configured, and in the network section, we have several networks that will be used for mid-haul and backhaul connection. Let's start with the CU instantiation. Click plus icon to launch the VM instantiation wizard. We're selecting the CU appliance template on the next screen. Now we must specify the CU instance name, and in our case, it's going to be CU VM. All other parameters like hardware resources already defined at the template level. We'll have to enter the CU specific configuration parameter. The first parameter is the AMF IP, which will be used by the CU to establish a connection with the 5G core. The second parameter is the CU IP address of the backhaul network. The third parameter is the IP subnetwork, which is used for the backhaul network. Next parameter is the IP address of the DU. In the scope of the setup, the DU is connected to the mid-haul network. The next parameter is heat wave on the mid-haul network, which is used by the CU to reach the internet connection, which is required for license validation. The next parameter is the CU IP address on the front haul network. This IP address will be used by DU to establish connection between the DU and CU. The next parameter is a subnetwork which is used on the mid-haul network. The last parameter is a set of configurations that are used by the CU and are specific for the particular RAN. These parameters come from the RAN vendor and they just copy-paste as is. Next, we must hook the CU appliance to the virtual network. At first, we are attaching CU appliance to the mid-haul for DU to CU communication using one of the pre-created virtual networks. In the same way, we are attaching CU appliance to the backhaul network, which is used for connection to the 5G core. Once those steps are completed, we click Next and the deployment is going to begin. We can see that the IP address was assigned to the CU instance, and we can start connection checking towards our CU appliance. It will take some time to bring up CU VM. Once it is up, We see that ping is successful. The next step is to check the reachability of the CU application instantiated inside of CU appliance. As you can see, after the CU VM starts to reply, we may test connectivity towards the CU interface on the mid-hole network. It is going to take some time for Docker containers with the CU application to be bootstrapped, and once it starts replying, we can assume that CU service is up and registered at the 5G core. So let's bring up the 5G DU. For DU instantiation, a Docker Compose is used. Let's trigger DU deployment. Once DU started, we switch off the airplane mode on the user equipment. We can see that the 5G connection was established, and now we can try to validate end-to-end 5G network and connection using applications like ping. Let's use ping application and let's try to ping a resource. You may see that packets are hitting Google, so it means that our 5G connection is up and running. Thank you for watching and see you in the next screencast.